This video goes over the day one portion of lesson 11.5 on angle relationships in circles. The essential question is, how do you find the measures of angles formed by lines that intersect circles? As we look at lines that intersect circles, there are going to be 3 theorems and 3 places where those lines can intersect. For our first theorem, we're looking at a tangent and a secant or a chord that intersect on a circle. Let's underline that. Tangent and a secant or chord intersect on a circle at the point of tangency. If that's the case, then the measure of the angle that's formed is going to be half the measure of its intercepted arc. In our picture here, notice that ray BC is a tangent. It only intersects the circle at that one point, point B, and point B is the point of tangency. And then the ray BA is a secant. It's a secant because it intersects the circle at 2 positions. This theorem states that if the tangent and secant intersect on the circle at that point of tangency, which is what we have right here, then the measure of the angle is half the measure of its intercepted arc. So that means the measure of angle ABC will be equal to 1/2 the measure of arc AB. You can also write this the other way around and say that the measure of arc AB is twice the measure of angle ABC. And we'll use both of these. If we're given the measure of the arc, we can take half of it, divide it by 2. And if we're given the measure of the angle and we want the measure of the arc, we can double it by multiplying by 2. I'm also just going to have you add to your notes somewhere, wherever it fits in your notes packet, somewhere write that this first theorem applies when we intersect on a circle. Notice that in example 1, you can see that the tangents and secants, they all intersect on a circle. So we're going to use that theorem above. Now, the measure of the angle STU, that is this angle right here, STU, is equal to 1/2 the measure of the arc. And the arc that's formed by that, arc ST, we can see is 166 degrees. We need half of 166, which is really just 166 divided by 2. You divide that out and you end up with 83 degrees. It helps if you fill in the picture as you find some measures. So I'm going to write a 53 right there. Next, let's look at the measure of arc SR. That's the measure of this. Here we're going the other direction. The measure of the arc is twice the measure of the angle that's formed by the tangent and secant. So twice the measure of SRQ. And that's going to be 2 times 71. So we have 142 degrees for the arc. And now to finish this example off, we need to find the measure of arc RT. And we don't know the angle across from it, and we can't assume that we know that angle. But what you should notice here is that we have the other parts of the circle. This arc is 166. The other arc is 142. We know that a total circle is 360 degrees. So let's take our total 360 and let's subtract the sum of the 2 arcs that we already have, 142 plus 166. Add that together, you get 308, and 360 minus 308 is 52 degrees. Using that idea that a circle is 360 degrees is going to help you with many of the problems in this unit. Go ahead and try the try now. Please pause your video, and then when you hit play, I'll have the solution posted. Here's your solution. To find the measure of angle BCD take half the measure of the intercepted arc, 142, and that's 71 degrees. For the measure of arc ABC, that is double the 90-degree angle that is forming that, and 2 times 90 is 180 degrees. And then to get the measure of arc AB, you can use the fact that ABC is 180 and BC is 142. Well, 180 minus 142 is 38. I also showed another way you could get it. You could get this angle right here to be 19 degrees by taking 90 minus 71. And then if we double 19, that will also give us 38 degrees. A lot of times there's more than one way that you can get your answer. For our next example, we're going to look at what happens if the secants or chords intersect inside the circle. If two secants or chords intersect in the interior of a circle, then the measure of each angle formed will be half the sum of the measures of the arcs intercepted by the angle and its vertical angle. In the picture over here, notice that chords AD and BC intersect at point E, and that intersection point E is inside the circle. This theorem states that the measure of that angle formed, angle 1, is going to be 1/2 the measure of its intercepted arc. That's going to be 1/2 of the measure of arc AB plus the measure of the arc that's the vertical angle to that. So these two angles here would be the vertical angle. So the second arc is arc CD. As an example, look here, you can see that to find the measure of SQR, which again, we see where they intersect inside the circle, we can go ahead and say, well, the measure of SRQ is half the sum of the measure of its intercepted arc, which is arc SR, plus the measure of the arc of its vertical angle, which is going to be arc PT. Now let's just put our numbers in. We need 1/2 of 100 plus 32. Well, that's 132, and half of 132, we can take 132, divide it by 2, and that gives us 66 degrees. To find the next angle, you don't actually need to use the theorem. Angle PQS is the angle that's right next to angle SQR. And notice that together, these two angles are forming a line. We know a line is always 180 degrees. So to get PQS, we can just take 180, subtract 66, and that is 114 degrees. This angle here would be 114, and then its vertical angle would be 114, meaning that if we find one angle inside the circle, we can also find the other three using linear pairs and vertical angles. Here's a try now for you to try on your own. We want to find the measure of angle ABD. Please pause the video now and give this a try. Here's your solution. The measure of angle ABD is half the sum of its arc plus the arc of its vertical angle, which is arc EC, 37. Well, 65 plus 37 is 102. And then divide that by 2, and we end up with 51 degrees. The last scenario that we can have is if the tangent and secant intersect outside the circle. Here, if a tangent and a secant two tangents or two secants intersect in the exterior of a circle, that's outside the circle, then the measure of the angle formed is half the difference, meaning we're going to have to subtract, of the measures of its intercepted arcs. Notice there are three different pictures here. It just shows every possible combination of tangents and secants. You can either have, like this first one, we have a tangent and a secant that intersect outside the circle. The second one, we have two tangents. And then the last one, we have two secants. When these intersect outside the circle, the measure of that exterior angle is half the difference between the intercepted arcs. So looking at the picture for the tangent secant, the measure of angle 1 will be 1/2 the arc that's the biggest, that's going to be the one furthest away. So measure of AD minus the measure of the smaller arc, which is arc BD. And the same pattern is going to hold true for the remaining two. In this middle one, the measure of angle 2 formed by those two tangent lines will be equal to the difference of the intercepted arcs. So that will be 1/2 the measure of arc EHG minus the measure of the smaller arc, arc EG. And then for our final case, secant, the measure of the angle, angle 3, is going to be 1/2 the difference of the arc. So again, the big one goes on the outside, the one that's furthest away. Measure of arc JN minus the measure of KM. And there we have our theorems. When you do your CYU and your next assessment, you're going to notice that the problems are not in any specific order. You're going to have to be able to recognize whether the secant and tangent intersect on the circle, inside the circle, or outside the circle. Because depending on which case that is, that's going to tell you which theorem to use from this section 11.5. Now let's find the value of x in each of these pictures using tangents and secants that intersect in the exterior of a circle. Notice that PR is a secant, it intersects the circle twice, and PS is a tangent. Well, the measure of the exterior angle, the x, is going to be half the difference of the measures of the intercepted arcs. So that's 1/2 the outer arc, 174, minus the inside arc there of 98. Subtract that first to get 76, and then half of 76 is 38. The one next to it also has two secants that intersect outside of a circle, but this time notice that I am actually missing this arc right here. Setting it up, we have the exterior angle 25 degrees, right? That's my exterior angle, that's my outside angle, just like the x in this first picture was the exterior angle, the outside angle. 25 degrees is equal to 1/2 the difference of the measures of the arc. So that's arc JN minus the measure of arc KM. Plugging in the values that we know, 25 is equal to 1/2 of 83 minus x. To clear the half, you can multiply each side by 2. And that'll give us 50 equals 83 minus x. Half times 2 is 1, and multiplying by 1 doesn't change anything. So from here on out now, we can just solve this by doing some basic algebra. I'm going to move the x to the other side by adding x. So x plus 50 is equal to 83. And then we can subtract 50 from 83 to give us x equals 33 degrees. Before we get to the try now example, I'd like you to add this to the additional examples section in your notes. This problem is actually number 3 off your 11.5 CYU. Notice that the angle that's formed outside the circle is formed by 2 tangents. And when you have 2 tangents, you might not be given the measure of both of the arcs, but you can figure it out. This inner arc right here is 140 degrees, and then the outer arc is really just the rest of the circle. Well, a full circle is 360 degrees. So that blue arc that I just drew there is whatever 360 minus 140 is. And you can see that is 220. And now we have both of the numbers that we need in order to find x. X, that exterior angle outside the circle, is half the difference of the intercepted arcs. We take that 220, we subtract the 140, and then whatever that is, we divide it by 2. Subtracting that, we have 80, and then half of 80 is 40. So our x value is 40 degrees. The final example here is a try now. It looks pretty similar to the last example. You can see that the measure of that x, the x is the exterior angle, so x is equal to 1/2 the difference of the intercepted arcs. So that's half of 87 minus 7. Well, 87 minus 7 is 80, and half of 80 is 40, meaning x is equal to 40 degrees. This concludes lesson 11.5 day 1. We'll go over the last example that combines everything together in the 11.5 day 2 video.